Hey everyone, Stelvio here. Welcome back to the channel where we break down data architecture and everything in between. If you are into database and tech, make sure to hit that subscribe button here below, like this video, and share with your datamates. Today we are diving into the world of databases, but not just any databases. Look at that. There are so many types, relational, graph, time series, NoSQL, vector, blockchain, and more. But what do they all mean? And more importantly, when should you use one over another? Stick around and we unpack all the different kind of databases, explore real-world use cases, and help you to choose the right tool for your data-driven solution. Let's go. First of the list are the relational databases, one of the most widely used database models in the world. So let's break it down. What exactly is a relational database? A relational database stores data in a structured format using tables with rows and columns. Each row represents a record and each column represents a specific attribute of that record. A simple table example could be a user table with column for ID, name, email, and a date joined. Think of it like a spreadsheet. Every row contains information about a specific entity, and the column define its properties. But unlike a single spreadsheet, relational databases are highly optimized for complex queries and transactions. Relational database use SQL, structured query language, to store, retrieve, and manipulate data. For example, if we want to find all the users who joined in the last month, we could run a simple SQL query like this one. Relational databases are perfect for application that requires banking systems when transaction must be processed in a secure way. Enterprise applications such as custom management or HR systems, e-commerce platform where data on products, customers, and orders must be well organized. Some of the most popular relational database management systems include MySQL, PostgreSQL, Oracle, and Microsoft SQL Server. A famous real-world application that relies on relational databases is Amazon. Amazon needs a system that assure fast transactions, data consistency, and high availability, which is exactly what a relational database provides. So to summarize, relational database store data in structured tables, making them ideal for handling large, complex data sets. They use SQL to query and manage the data in an efficient way. They are widely used in banking, enterprise application, and e-commerce. And some popular examples are MySQL, PostgreSQL, Oracle, and Microsoft SQL Server, with Amazon well known example of a relational database in action. Alright, let's talk now about NoSQL database. Unlike traditional relational databases, NoSQL databases are designed for unstructured or semi-structured data, perfect when flexibility and scalability matters most. But where do we use them? Web applications, for instance, content management systems, and real-time applications all benefit from NoSQL speed and efficiency. Think about social media feeds, for instance, or recommendation engines, or massive social cloud storage. Now, NoSQL isn't one size fits all solution, of course. It comes in different types. So we have document oriented like MongoDB and CouchDB, great for flexible JSON based data. Then we have the key value stores like Redis, for instance, DynamoDB, perfect for caching and session storage. Then we have the column family stores, think Cassandra, HBase, built for handling massive amount of data. Then we have the graph databases like Neo4j and ArangoDB, ideal for complex relationship. Choosing the right NoSQL database depends on your use case. Which one do you think fits your project best? Moving on to the columnar databases, what exactly is a columnar database? Well, unlike traditional row-based databases that store data in rows, as we have seen, columnar databases store data in columns. This is exactly a huge advantage when it comes to data analytics, for instance. To give you an idea, let's say we are working with a table that holds customer information in a row-based database. Each record will store all the information in a single row, name, address, phone number, etc. But in a columnar database, all the values for each individual column are stored together, making it super efficient for certain types of queries. Columnar databases, as I said before, are optimized for data analytics, particularly when you are dealing with large volumes of data. This is perfect for operation like aggregation, filtering, and scanning through huge data sets. So if you are working in a field where you need to pull up a large chunk of data very quickly, such as, for instance, data warehouses, business intelligence tools, or analytic platforms, columnar databases are the way to go. Think of scenarios where you are generating complex reports or analyzing large data sets that won't change too much. To wrap up, columnar databases excel at handling analytics-heavy workloads where speed and efficiency in data retrieval are critical. If your system requires high performance analytics over massive datasets, a columnar database could be a game changer for you. All right, let's now go ahead with the WideColumnStore Databases, a powerful database model designed to handle big data and real-time analytics. What exactly is a wide column store database? Unlike traditional relational databases that store data in rows and columns, wide column stores focus on storing data in columns rather than rows. This makes them really efficient for reading and analyzing large data sets. In a wide column store, tables don't have a fixed schema. Instead, each row can have different set of columns, making it super flexible for handling huge data sets where not every record follows the same structure. For instance, this is especially useful for big data applications where data keeps changing dynamically. Wide column store databases are widely used in big data analytics, real-time processing, and high-performance application. For instance, they are commonly used for storing and analyzing user activity logs, handling real-time recommendation systems, managing large-scale IoT data streams. Some of the most well-known wide column databases are Apache HBase and ShilaDB. These databases are designed to scale horizontally, meaning they can handle petabytes of data across multiple servers while maintaining high availability and low latency. A famous real-world application that relies on a wide column store is Facebook Messenger. Since Messenger needs to handle massive amounts of data, chat data, including text, media, and metadata, provides a flexibility and scalability needed to store dynamic users. Netflix uses Apache Cassandra, for example, to handle massive amounts of data related to user activity, viewing patterns, and recommendations, supporting millions of users across the globe. So to summarize, Wide column store databases store data in columns instead of rows, making them highly efficient for big data applications. They are great for real-time analytics, log processing, and scalable storage. Popular examples are HBase from Apache and SheilaDB, with Facebook Messenger being a real-world example. You might wonder at this point, what is the difference with the columnar database? Well, there are many differences, as you can see in this table, and to summarize, let's say columnar database are best for analytics and data warehouses, and wide column stores are a type of NoSQL database optimized for big data and real-time application, allowing each row to have different columns. And that's wrap on today dive into databases. I hope you find this breakdown helpful. If you enjoyed this video, don't forget to hit the like button, subscribe, and turn on the notification bell. Also, let me know in the comment section down below what's your favorite database. Thanks for watching, and I'll see you in the next one. Stay curious, keep learning.